To demonstrate this smoothing function, which is already part of the function development JavaScript files, I will be using VBA code, basically an Excel macro, which replicates the procedure, and it should demonstrate graphically what is going on. So if I take all the root data from the rail alignment array, I go into the Excel file where we can paste this information. I will remove excess information. From here we have formulas which convert latitude to decimal degrees, longitude to decimal degrees. Existing, we could put it as 0, and that was what would activate the function. I'm going to put some random numbers. Random numbers regenerate every time you enter a formula. So if we put an alignment anywhere in the world, we do not know what values we will receive, so random numbers are applicable. We have a proposed track type and number of lines. These are the additional columns again that I'd like George to add to the array, namely here. And you can see on the graph this plot, which are these random numbers based against this length. So I will be running this macro, and this should populate these cells based on a forward series of passes, a backward series of passes, which should result in an average. So if we run the macro, hopefully you can see what happens in the graphical area. So as a result, we can see that 3 plots have been made. One is the forward, the green one is the backwards, the purple one, and the average between the two. So the forward runs using the existing gradient. When I say existing gradient, this is the maximum gradient a railway can achieve going vertically, and that is stipulated here. So that determines the steepest profile that you can achieve. Similarly, the backward does the same process, and eventually these two going backwards and forwards will converge after a series of loops. We take the average, and that is what would be the proposed elevations. What this does is generates the best profile based on the maximum gradient for a piece of land with no assets crossing it.